Ever since we first looked up at the stars, we've been wrestling with this one massive question. It's shaped everything: our stories, our beliefs, our science. So, what kind of universe are we actually living in? Let's dive in and explore some of the wildest possibilities out there.
So yeah, this is the question, isn't it? It's what drives all of cosmology. I mean, think about it. Does this thing go on forever? Or is there some kind of cosmic edge out there? Are we it? Or are we just one tiny piece of a much bigger puzzle? And maybe the biggest one, how's it all going to end? Let's follow the clues the science has given us and see where they lead. All right, a question that huge can feel, well, a little overwhelming, right? So where do we even begin? Simple. We start right here with what we can actually see. Before we get into all the really mind-bending stuff, we've got to get the lay of the land in our own cosmic neighborhood.
Okay, so this is what basically defines the edge of our vision. The universe, right? It's about 13.8 billion years old. And since nothing can travel faster than light, that creates this cosmic horizon. Think of it like this. Light from anything super far away just hasn't had enough time to get to us yet. It means we're stuck inside this observational bubble. And what's outside? For now, we just can't see.
And this is where things get a little weird. You're probably thinking, wait a minute, if the universe is 13.8 billion years old, how can we see something that's 93 billion light-years across? Great question. And the answer is expansion. While that ancient light was making its long journey to us, space itself was stretching out. It's like trying to run on a treadmill that's constantly getting longer. That cosmic stretch is what blew up our little bubble to this absolutely mind-boggling size.
So, the million-dollar question is, what's outside our bubble? Well, it really boils down to two main ideas. On one hand, the universe could be finite. Now, that doesn't mean it has an edge. Think about the surface of a globe. You can walk forever and never fall off. You just end up back where you started. The universe could be like that, but in 3 dimensions. Or it could be infinite, just endless space, forever. Right now, our best guess is that it's flat, which kind of points towards infinite. But honestly, we're just not 100% sure yet.
But here's something we do know for sure, whether it's finite or infinite. Our universe is not just sitting still. Oh no, it is constantly on the move.
For the longest time, everyone, even Einstein, thought the universe was just static, unchanging. But then, an astronomer named Edwin Hubble made a discovery that changed everything. He noticed that faraway galaxies weren't just moving, they were all rushing away from us. And this wasn't just them flying through space, it was the fabric of space itself stretching out like a rubber sheet and carrying all the galaxies along for the ride.
Okay, so if the universe is expanding now, just think about it in reverse. It must have been smaller yesterday, and even smaller the day before that. If you run that cosmic film backward, all the way back, you end up at a single point, and that's the Big Bang. Now, it's really important to remember, this wasn't some explosion in space. It was the beginning of space and time itself, emerging from this unbelievably hot, dense state.
And look, this isn't just some wild guess. The evidence for it is overwhelming. But the biggest smoking gun has to be the cosmic microwave background. You can think of it as the leftover heat, the faint ancient afterglow from that initial creation event. It's literally everywhere we look in the sky, cooled down over billions of years. It's like we can still hear the echo of the universe being born.
So we've talked about the beginning. But if the universe had a start, and it's always changing, it makes you ask a much darker question. How does it all end? And let me tell you, the possibilities are straight out of science fiction.
So really, this is the central question, right? Will it just keep expanding forever? And the answer comes down to this epic cosmic tug of war. On one side, you've got the outward push of that initial expansion. On the other, you've got the inward pull of gravity from all the stuff in the universe trying to reel it all back in. And just to make things interesting, there's this mysterious wild card called dark energy that's actually hitting the gas pedal, making the expansion speed up.
So depending on who wins that battle, we're looking at 4 pretty wild endings. First up, the big freeze. This is where expansion wins. Everything just keeps getting further and further apart until the universe is a cold, dark, empty wasteland. Then there's the big crunch. That's if gravity wins. Everything gets pulled back together into one final fiery singularity, a big bang in reverse. The big rip is the craziest. That's if dark energy goes nuts and accelerates so fast that it literally tears galaxies, stars, planets, and even atoms apart. And then there's the big bounce, the idea that a big crunch could trigger a new big bang and an endless cycle of cosmic death and rebirth.
So which one is it going to be? Well, based on everything we can measure right now, the smart money is on the big freeze. It's often called the heat death of the universe, and it's not some big, flashy explosion. It's a slow, quiet, lonely fade to black. The stars will all burn out. The black holes themselves will eventually evaporate over trillions of years. And all that's left is a vast, cold, dark, and empty void, where nothing ever happens again. A perfect state of disorder forever.
Okay, but what if the end of our universe isn't really the end of everything? What if this entire cosmic show we've been talking about is just one tiny stage in a much, much bigger theater? Now we're really stepping beyond what we can see, into the truly speculative.
This is where we get to the idea of the multiverse. It is a completely mind-altering concept. The idea is that our entire universe, everything we can see and everything beyond our cosmic horizon, is just one bubble, and it's floating in a vast cosmic ocean, a foam of other bubble universes. Each one could be totally different, with its own laws of physics. We're not just talking astronomy anymore. We're diving deep into theoretical physics here.
And it gets even crazier, because scientists talk about different levels of the multiverse. Level 1 is the simplest. If our universe is infinite, then way, way out there, beyond what we can see, there are other regions just like ours. Level 2 is where universes are born with different laws of physics. Maybe gravity is stronger or light is slower. Level 3 is the quantum one, the idea that every possible outcome of any event splits off into its own separate universe. And level 4? Hoo boy, that's the idea of universes built on completely different mathematics, something we literally can't even imagine.
So, just when you think things can't possibly get any weirder, we have to consider the final, most profound possibility of all. A question that doesn't just challenge what we know about the universe, but what we think of as real itself. What if none of this is real?
Yeah, we're talking about the simulation hypothesis. This is the truly radical idea that our entire reality, you, me, the stars, the laws of physics, everything, is nothing more than an incredibly advanced computer simulation. It sounds like something straight out of a movie, I know, but it is an idea that's taken seriously by some very smart philosophers and physicists.
So what's the evidence? Well, that's the thing. There's no direct proof at all. The main argument for it is just a numbers game. It goes like this. If it's even possible for a civilization to create a realistic simulation, they won't just create one, they'll create billions. So, statistically, the odds are way higher that we're in one of the billions of simulations instead of the one single base reality. But the argument against it is a big one. We can't test it. There's no experiment we can do to prove it's false. So for now, it's just a fascinating and maybe a little terrifying thought experiment.
So where does all this leave us? It leaves us staring at this absolutely incredible menu of possibilities, doesn't it? Our universe could be a finite bubble, or it could stretch on forever. It might be the only one that exists, or just one in an endless sea of others. It could be destined to fade away, or maybe it's eternal. And it could be the fundamental reality, or it could just be code running on some supercomputer. I mean, every single one of those ideas is just huge.
And so we're right back where we started, asking that same exact question. We don't have the final answer. Not yet. But maybe the answer isn't the point. Maybe the real point is the journey, the incredible human drive to keep asking, to keep exploring every wild idea from a lonely, finite bubble to an infinite, simulated reality. It is, without a doubt, the greatest mystery of all. So the question is, what do you think?